Hello everyone and welcome back. Today we're going to be talking about a problem near and dear to my heart. So I've got a 3D printer, which most of you are fairly aware of, and there are certain use cases for that where you make something really cool that just looks cool, sits on a shelf or whatever, and I've done quite a bit of that, and that has shown up on the channel a bit. And there's also the practical side of 3D printing. Now, if you've got a 3D printer and you've only been printing things that have been pre-made, this is for you, because this is going to show you how I approach designing a new something to print on my 3D printer that is useful to me. So I'm not going to be starting from scratch, and right now on your screen you ought to be seeing a photo of a paint from Hobby Lobby. So this is just generic paint from the cheap aisle, and I've been using it to 3D printed minis. Now, I've got a handy dandy rack for storing my model-specific paints. Like, I've got some Vallejo, I've got some other different brands of paints that I use to paint my models, and it's great. Somebody went out and designed a functional print just for carrying and storing that in a visual way that is easy to use. But it doesn't fit the cheap stuff. So right here we have said bottle of cheap stuff, and I pulled out my digital calipers, and I have taken some measurements. So everything in here is going to be in millimeters, and that's totally fine. You can use whatever units you want, but I think you're going to find that working in metric is probably going to be the easiest for you, as it is for me. It's taken a little bit of adjustment, seeing as I'm American and we use freedom units. But yeah, anyways, this is the diameter of the bottom, the widest measurement. And when we go to create this, we're going to be rounding up just a little bit, because a perfectly tight fit may or may not fit. Little known fact about 3D printers: if you're printing a functional part, it actually matters. There's going to be some swell in the print, so the plastic gets a little bit bigger than it's supposed to, so all of your internal dimensions are going to be a little bit too small. So we're going to round up and make sure there's enough space that this will fit, and that the air will get around it, so that when I put in and pull out, it'll work. And we're going to go on to capturing the other critical dimensions. So this is the size of the cap, if we wanted to store it upside down, which I will show you is one of the options in the other paint type. Let's see, moving right along, we've got the length, like the total length. We're probably not actually going to be using that, other than to subtract this right here, the cap like depth. So we're going to subtract the measurement here from the overall measurement, and that will give us how tall the cap is. So if we want to store it upside down, we can. And that is the last reference picture that we've got for this project. Right here is that set that I was talking about, where I have printed several of these, and I'm storing some of my model paints, and it works great. Some of the paints fit in there right set up, upside down, however I want, and it's also got some spots for brushes. Love it to death. And if you want to follow along and build this yourself, you're going to have to go over here to Thingiverse and grab this specific model. Now, it's not super duper complex, which is great. A lot of time and effort and thought has gone into it to make it easy for the end user, so me in this case. I like it. It does good stuff. It doesn't fit my current paint setup. So what we're going to do is we're going to download that. At the current time of recording, the download all files button does not work. So if you want to download something from Thingiverse, then you're going to have to download each individual file and stick it in your own folder, which I have already gone ahead and done. This with anywhere, really. Find a model that you like that's pretty close to the purpose you want to design for, and that's what you start with. So we're going to move right along to Tinkercad. So if you don't have a Tinkercad account, it's really not that hard to get one set up. So I would highly suggest going and setting up a Tinkercad account. And when you first start, up at the top left-hand corner of the screen, you're going to have a new project button. So this one has gotten the fabulous name of Fabulous Wassajikes, or whatever. I don't know. I don't think it's actually supposed to be human pronounceable. It is just a placeholder name. So we're gonna rename this to Paint Holder so that we've got a good descriptive name. Yes, I could do better, but realistically, I'm making one thing for me, and I'm not sharing it out to everybody just yet. Maybe at the end of the project, we'll see what we're going to do there. So next up, we're going to click outside of that so that we've set the name, and we're going to go to the import button. And from here, I can grab and drag and drop one of the files. Here we go. I have dropped in one of the files that we downloaded. This is, like I said, not super duper complicated. We're going to leave the scale at 100%, and it has already auto-grabbed all of these dimensions from inside the file. We're going to go ahead and hit import and wait for that to do its work. Okay, so we finally have this model loaded in, and as you can see, it takes up the majority of the build plate. Tinkercad is designed with 3D printing in mind, as far as I can tell, just building easy 3D printable things. So what we're going to do is we're going to take those reference images and we're going to use that to build up something to interface with this. So what we want to do is we want to start with a cylinder as a whole, because that is the general shape of what we're trying to print, right? And if I go over to the reference image, I can see that it is 33.8 millimeters in diameter. Like I said, we're going to round up. We're going to go to 30, let's see, 5. And you see that changes it in one direction. So we're going to change it in the other direction. There we go. We have a 35 by 35 cylinder. Now, it's not tall enough. Right now, it's 20 millimeters tall. So once again, we're going to take a look at the reference photo. And overall, this larger section should be 76.1 millimeters tall. So we're going to just do 76 since height is not super duper important for this specific project. Okay, so next up we want to build the cap. So we're going to also bring that in. We're going to go back to our reference image, and if you remember, the measurement for the cap was 27.7. We're just going to round that up to 28 millimeters. 28 millimeters. Okay, so we now have a top for our bottle. So let's go ahead and bring this up. And you can either measure or you can just eyeball it like what I'm doing. Yep. Since we used all round numbers, it is properly on top. So to merge these, first we're going to hit the L key on your keyboard. You see it also activates this tool up at the top right. And we're going to align it in the X and then in the Y. Really doesn't matter which order you do that in. And just for the fidelity of the part, what we're going to do is we're going to change the sides to 64. And we're going to do that on both. And what that does, if you were watching, has smoothed out the sides a little bit. So I can actually turn that back into a solid. You can see the shaded bits each step that it uses for the straight lines to draw the circle. So just for demonstration purposes, we'll bring that back down to 12. Yeah, that is an approximation of a circle using straight lines, but with only 12 segments. So it's not very good. Okay, so we're going to bring that back up to 64. This is processor intensive for your browser, so everything's run in browser, but it also will slow it down if you have too many parts with too many facets. which is what we were just talking about. So next up, we've selected both parts again, and we are going to group them. If you want to use your keyboard shortcut, is Control G for group, which is this tool up here, Control G. Then we've also got the ungroup, which is Control Shift G. Now, if I had slightly misplaced one of these two bits, what I can do is I can double click on it, and that last grouping will break into individual parts again. There we go. We have our individual parts. Since we did everything exactly the way that we wanted, we're going to see what it takes to interface with this piece over here. So to interface, what we're going to do is we're going to use our handle at the top to rotate. And if we are on the inside of the circle, it will go in chunks. Or on the outside of the circle, it's going to go in single degree increments. And we don't need that kind of granular control. We're going to turn it 180 degrees. That's exactly upside down. And we're going to move our model back in. So let's move this in here and see if we can center it on one of these X's. So if you're close but not quite there, you can use the arrow keys. They're all relative to where you're currently looking. So bump that over just a touch, and it looks to be centered on that hole. So you can see how much change there is between the size of the bottle that I have versus the holder for the other types of bottles. Now, if we group these here, the hole into the solid part, then it would go all the way through on the bottom, because this bottle model is all the way on the build plate, on the work plane. So that's no good. This is going to go straight through. What we're going to do here is we're going to grab that handle on top, and we're going to move it up just a bit. So each little step moves it up a little bit more. And really, we could just match it up with the bottom of one of these holes. So let's go down one. You see it changes color because it's now intersecting. There we go. Now it should be lined up perfectly with the bottom. So let's select both parts, and we're going to use our Control G again to group. And you see how that hole has changed. So it will still hold all of the paints that I want it to, but it won't work upside down anymore, which is okay. Because this rack is going to be specifically for the cheap paints. So really, I just need to do this a couple of more times, but I just lost my part. How do I make more? Well, we're going to use that shortcut that I was telling you about earlier, where we can double click. So we can select the two parts that were just grouped together, and we're going to use Control C to copy, which is up here. And then we're going to use our Control V to paste, which is also up here. So we can actually figure out what that offset should be if we want. Or we can just use our arrow keys to bump it over just. And it looks like they don't nest quite as nicely as the others do. But as long as we keep the external dimensions together, it will still match up. Let's go ahead and group those back together. And I'm just going to do that a couple of different times, and we will come back once I have a final part. I may actually also come through and do a different one, because I don't have this many of the cheap paints. I may go down to the 3x3 or the 3x4 or the 2x4. We'll see. But also, before we go anywhere, I want to copy. Okay, we can click outside, and that will remove that. And then we're gonna rotate quick, 180 degrees. Move it over one of these others. Then we're gonna nudge it into place. and then we're going to bring it off of the work plane until it matches up with the bottom there. So this is going to make a slightly more flimsy part, but it'll work. So we're going to have them sitting upright, and over here we can have them sit upright or upside down. But yeah, I'll see you after I finish filling in all of these with new holes that will fit the new. Okay, so this is after the break. We've gone ahead and made sure all of these holes are filled with our holes. So just for reference, we'll temporarily split the part so you can see what goes in here. And that's what we've got. So these, said before, are a little bit bigger than the previous bottles they were designed for, and we didn't maybe make a perfect connection with the bottom on a few of these, but that's okay, because it's close enough for me. So to continue on and actually 3D print this design, all we're going to have to do is hit export and then an STL, and it's going to download that for us, and then we're going to bring it into our favorite slicer and go ahead and actually make this thing. So I think I'm going to print this on my Prusa Mini. So we're going to open that up, and once that opens, we will go ahead and drag that in there. Nope. Nice and easy. So some of these sharper edges are not going to print very well, but that's okay. So for what I like to use the 20mm quality settings, just because for some reason some of the fast or draft settings don't really work all that well. But this is a functional part. We're going to take a look at what kind of infill we want. 15% is fine. Gyroid is not. Cubic is, generally speaking, the fastest printed infill type. Then we're also going to go up here to layers, and we're going to take a look at the quality slower slicing settings. We're going to do extra perimeters if needed, which is totally fine. Avoid crossing perimeters, not super important for this specific one. Totally fine if we cross perimeters. We're just going to clean it up. If you're printing something that's supposed to look really good, maybe don't do that. Go ahead and detect thin walls. Sure, why not? Detect bridging perimeters is already on. And let's see, is there anything? Yes, external perimeters first. So that's probably the best thing you can do for good surface finish. And I think, and correct me if I'm wrong, that's also the right way to get it to be the right shape on the outside. So what it does is it does the outer perimeter and then it does the infill in the inner perimeters. And by doing that, what happens is you've got a nice smooth outer layer, and it's not influenced as much by the layers on the inside. Something else that I like to do, we're gonna go ahead and hit slice and see how long this is gonna take. The estimated print time is 10 hours and 34 minutes. So let's step down through the layers and see how much actual infill there is. So you want to check before any flat layers to see if there's enough infill to support a flat layer. And there absolutely is. Look at how much infill that is. That's a lot. Probably cut that back down to about 10%. Yes, this is a functional part. Yes, you want more infill than something that just looks pretty and sits on a shelf. But it doesn't have to be that robust. If you need more strength, generally more perimeters. So as long as this is good enough to give us the support we need for each of these layers as they come in, it looks like, yes, looks like we do. Okay, so we went down from 10 hours to just under 10 hours. Now, that's still not the fastest we can get it, so we're going to go back over here to the plater, and we're going to use the variable layer height. And we're going to check to see if going fast on our layer height actually improves how fast it prints. Now, it's really flip of a coin whether or not it actually does make it faster, but what this does is it varies the width, or not the width, the height of each layer, as demonstrated by this graph over here on the side. so that we can print layers faster. So taking a look at this, as I hover over, I realize that's kind of small to read. It is 0.25, which is higher than the print settings that I selected, because I selected 0.2. So yes, that is actually quite a bit bigger. But you'll also notice, you see it highlights all of the flat surfaces. It goes down to 0.14. So it goes real slow on the flat surfaces. So you've got a good, smooth, high detail flat surface. So let's go ahead and slice it and see if we saved any time. We did. We saved an hour and a half roundabout. It went from 9 hours to 8 hours and 22 minutes. So this is what we're going to actually print. As you notice, each of these sharp areas aren't quite as sharp. They've been rounded out by the actual plastic. So let's see. I'm going to go ahead and print this, and we'll see about getting you guys a time lapse to slap in here. And we'll take a look at the finished part and see how it fits. And here we go with the test fit. So as you can see, slots in just fine. Holds it decently tight. Fits in upside down acceptably well. It's a little on the tight side. There we go. Nope, that's a bad idea. Very nearly untied it, or unscrewed it. But that's this little bit here that we didn't account for, and this little lip here that we didn't account for. But it sits in there just fine. And as you can see, what I did is I printed a little bit smaller than your average. Also, this needs to be fixed. I didn't have enough distance between the bottom where this top is supposed to sit and the actual bottom layer. So I will thicken that up, but that's why I printed this smaller test piece. Also, I probably want to go in and upsize it just a touch to make sure these walls are a little bit thicker, because you can see through those, and that's not great. But yeah, for a test print, that works just fine. And if I want to print the full size, I already have, one full size ready to go. Well, it looks like that's going to do it for us today, guys. I wanted to say thank you for hanging around this long. If you did and you haven't already hit subscribe, please do. Just so you don't miss out on any of the other cool stuff coming on down the road. If you'd like to hang out with us, please hit us up on Discord. Link is in the About section on the channel, or you can go to discord.wonsnot.com, and I will see you guys in the next one.